Good day to all of you. Next we shall discuss question 4a from model question paper set 1. So define encoder, design a 4 input priority encoder. So this is asked for 5 marks. Solution: an encoder is a digital circuit which has 2 raised to n input lines and n output lines. The output lines generate the binary code representing to the input value. It does the inverse operation of decoder. A priority encoder is an encoder circuit that includes the priority function. The operation of the priority encoder is such that if 2 or more inputs are equal to 1 at the same time, the input having the highest priority will take the precedence. So that is what is encoder and priority encoder. Next we shall see to designing of 4 input priority encoder. So this is the truth table for 4 input priority encoder. These are the K maps to get the simplified expression for its outputs. So 4 inputs are taken as D0, D1, D2, D3. So these two are the output bits X and Y, and the third output bit, that is V for valid. So if this is 1, these two outputs will be valid. If this is 0, the outputs are not valid. So here when all the inputs are 0, which is not allowed because any one has to be 1, but all are 0, so the valid bit is 0, indicating whatever be the bits on XY output, they are not valid. That is don't care condition. When D0 is 1, when all other input bits D1, D2, D3 are 0, so this valid bit 1 shows that X and Y both are 0, 0, indicating D0 is active. When 0, 1, indicating D1 is active irrespective of bit D0, even if it is active, higher priority is given for D1 than D0. Here higher priority is there for D2 than D1, for D3 than D2, D1, D0. So now if D1 is 1, the output XY are 0, 1, the valid bit is also 1. If D2 is 1, whatever be the bits on D1 and D0, priority is there for D2, hence the output is 1, 0, that indicating D2 is active. So 1, 0 indicates that D2 is active, that is 1. So valid bit is 1. So when D3 is 1, irrespective of D0, D1, D2, the high priority is there for D3, hence the output is 1, 1. Valid bit is 1. See, this is the K map for X output. So this is X output and this is the K map. The X output values are filled in K map because it is a 4 variable function. 2 raised to 4 squares are drawn. Only 2 ones are there in X output, but so many ones are filled in K map. Why? So that question arises here. So X equal to 1 here, but it is 1 when D2 is 1 and D0, D2 are don't care condition. X, X or cross mark means whatever be their values. Means they may be 0, 0, 0, 1, 1, 0, 1, 1. Hence when 0, 0, this one condition, when 0, 1, 1 condition, and 1, 0, 1 condition, 1, 1, 1 condition. So for all, instead of only one condition, for 4 conditions it is 1. Which are the 4 conditions? 0, 0, 1, 0, then 0, 1, 1, 0, 1, 0, 1, 0, then 1, 1, 1, 0. X output is 1 and that is filled here. For 4 conditions it is 1. So in this manner for other one also the K map is filled, hence instead of only 2 ones, many ones we have. Similarly for Y output here. After drawing we'll have to group and find the group ones and find the simplified expression. So for X it is 16 ones group we cannot draw. So 2 octets are possible. For the first octet, if you take these all 8 ones covered in 4 zeros, row wise nothing is common. Column wise this is 0 1 1 1. So this 1 is common, that corresponds to D3, that we have written here. Similarly for second octet, so they also fall in 4 rows. Row wise nothing is common, but this and this column in this, these all ones are covered. So here 1 1 1 0 means this 1 is common, that corresponds to D2, hence or D2 is written. That is what is X is equal to D2 or D3. So similarly for Y, we can realize after filling once one octet and one quad. For this octet, row wise nothing is common, but these are covered in these columns. 0 1 1 1 means this 1, that corresponds to D3. And this quad, if you take all 4 ones are covered in this row, 0 1 1 1, this 1 is common, that corresponds to D1. And for these 4 ones column wise, 0 0 0 1, this 0 is common, that is D2 dash. So D1 and D2 dash, that is for quad. D3 for octet. So D3 or D1, D2 dash is the expression for Y. That is the simplified expression for Y. If you observe V column here, so V is true for when D0 is 1, then when D1 is 1, when D2 is 1, D3 is 1, only then, hence this expression is directly taken from the truth table. Okay, so seeing these expressions, next logic diagram will be drawn as the part of implementation of 4 input priority encoder. So this is the logic diagram for 4 input priority encoder, D0, D1, D2, D3. Here X is D2 or D3. So here D2 is taken, D3 is taken, that is logically or, that gives X. And Y is D3 or D1, D2 dash. So here Y is, we have taken D3. Next, it is to be ORed with D1, D2 dash. So D1 is coming, D2 dash is coming, both are ANDed, and this is ORed with D3, that is equal to Y. V is D0 or D1 or D2 or D3. Here this V is equal to D0 or D1. Already here D2 or D3 is coming, and that is given here. This is what is implementation of 4 input priority encoder. Okay, I hope you understood, and that is the solution for question 4a. Define encoder, design a 4 input priority encoder, that was asked for 5 marks. Next, the 4b question is, write the Verilog program to implement full adder and subtractor circuits. This carries 5 marks. Solution, and this is the program for full adder, module, end module. This is the start of program, this is the end of Verilog program. The name of program we have taken full underscore adder. In bracket semicolon we write the list of all inputs and outputs. For full adder, X, Y, Z are the 3 inputs. Sum and carry are the 2 outputs we have taken. Input is, then out of this list of inputs and outputs we'll have to bifurcate and write here as per the syntax of Verilog program. Input is the reserved word, output also reserved word. Input X, Y, Z, X, Y, Z, semicolon. These are the inputs. Output carry, sum, semicolon. So we are indicating out of this list which are the inputs and which are the outputs. Then reserved word assign sum to some variable, to some output variable here. What is assigned? So sum equal to X XORed Y XORed Z semicolon. This cap symbol indicates logical XOR operation. As per the design of full adder, the expression for sum is X XORed with Y XORed with Z, and that is what is written here. Carry is xy or yz or xz. So that we write here. Assign carry equal to in bracket x and y. This is logical ANDing. This pipeline operator is logical ORing. So y and z or x and z. Within brackets we are writing the groups and semicolon. This is end of program. So this is the implementation of full adder in Verilog program. The expression for sum being x XORed with y XORed with z, and for carry it is xy or yz or xz. So this is the Verilog program for full subtractor. So the expression for sum and difference remains same. X XORed with y XORed with same, XORed with z, x XORed with y XORed with z. That was sum in full adder. Here it is equal to difference. Hence the variables are taken as, variable is taken as difference instead of sum. Borrow expression is x dash y or x dash z or yz. That is what is written here. X dash, that is with tilde x, means x dash, logically ended with y. So x dash y, or this pipeline operator as already told, logical ORing, x dash z or y z, means y logically ended with z. So here module, end module, start of the program, end of the program. The name of the program we have taken full underscore subtractor. This is the list of inputs and outputs. XYZ are the inputs, borrow and difference are the outputs. Full adder means that which adds three input bits. Subtractor which does the subtraction between three input bits. So input x comma y comma z semicolon. We are indicating, declaring which are the inputs here and which are the outputs here. Assign difference equal to x XORed with y XORed with z semicolon. Assign borrow equal to, so tilde x logically ended with y. This is one group logically ORed with. Then another group tilde x logically ended with z. Then next group which is logically ORed, that is y logically ended with z. End module. This is the Verilog program for full subtractor. Okay. And that is the solution for question 4b, which is asked for 5 marks. Next, question 4c. Write the characteristic table and equations for SR, JK, D and T flip-flops. So solution, this is the characteristic table for SR flip-flop and its equation. So S and R the inputs. 4 combinations possible are 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0 the next state will be same as previous state. So Q of t plus 1 indicates after clock cycle what it will be the next state of the circuit. Q of t means that is previous state. So next state will be same as previous state, hence it is no change. For S and R, if both the inputs are 0, 0. If 0, 1 means it is reset state, output Q will be 0. 1, 0 input, for that Q will be 1. That is set state. Q output will be set to 1. S and R both are 1. That will lead to indeterminate output state. That will create race around condition. We cannot say what will be the output. That is why it is called as indeterminate state. Hence both the inputs 1 and 1 for SR flip-flop, that has to be avoided. So the characteristic equation is Q of t plus 1 is equal to S logically ORed with Q of t logically ANDed with R. Then D flip-flop. Another name for D flip-flop is data flip-flop. In this output Q will be same as D. So this is D input, this is next state. So next state means after giving the clock pulse to D flip-flop. So Q will be 0 if D is 0. So next state will be 0 if D is 0. Next state will be 1 if D is 1. And the characteristic equation for D flip-flop is Q of t plus 1 is equal to D. Means the next state will be always equal to D. If D is 0, the output is 0. D is 1, the Q output is 1. Next, this is the characteristic table for JK flip-flop. JK are the two inputs. 0, 0, 0, 1, 1, 0, 1, 1 are the 4 possible combinations for the input. So the next state, that is q of t plus 1, means what will be the output? For j, k both are 0, 0, that is q of t means that is no change. Next state will be same as previous state. When 0, 1, j is 0, k is 1 means output q will be 0. That is called as reset state. J is 1, k equal to 0 means output is 1. That is called as set state. When both are 1s, j is 1, k is 1, q dash t means the next state will be complement of the previous state. That is why it is complement written here. Toggle flip-flop means, so t input when it is equal to 0, the output will be no change. Means next state will be equal to same as previous state. So when t equal to 1, the output will be complemented. If it is 0, it will become 1. If it is 1, it will become 0. Q of t plus 1 is equal to tq dash plus t dash q. This is the characteristic equation for toggle flip-flop. And the characteristic equation for jk flip-flop is q of t plus 1 equal to jq dash plus k dash q. So that completes the solution of question number 4abc. That is for 20 marks. A for 5 marks, B for 5 marks and C for 10 marks. Okay. I hope you understood. So that completes the solution of question number 4abc. That is for 20 marks. A for 5 marks, B for 5 marks and C for 10 marks. Okay. I hope you understood. Thank you.